This time I promise. Last problem. 5 cards, numbered 1 through 5, are placed in a box and mixed up so that each has the equal likelihood of being drawn. We draw 2 cards from the box. We want to calculate what's the probability that the sum of the numbers on the cards is equal to 5. Well, we can use our standard probability equation for this. Probability of event E is equal to the number of favorable outcomes divided by the total number of outcomes. Number of favorable outcomes over the total number of outcomes in the sample space. Boy, let's see. Let's think about this. We've got 1, 2, 3, 4, 5. Those are the cards. We're going to draw 2 of them, and we need to calculate the number of favorable outcomes, the number of ways that 2 cards drawn can add up to 5. Well, let's see. 1 plus 4 will work, won't it? 2 and a 3 will work. A 5 and no, nothing else works. There are only 2 ways that you can possibly pull 2 cards from this hat, add them together, and get 5. So there's our numerator, folks. There are 2 possible favorable outcomes. But what are the total number of ways that we can draw 2 cards from 5? This is sounding like a problem from our counting chapter, doesn't it? And yes, it certainly is. Well, we have to decide, is this a permutation problem or is this a combination problem? Let's see. Let's say I drew 2 and a 5. Would we care that another person draw a 5 and a 2, or would we say that's the same numbers? Does it matter which order we're drawing them in? No, it doesn't. In this case, we're looking at a combination problem. And so in our denominator, the total number of outcomes is simply 5 select 2. How many is that? Well, I haven't done that problem, so I'll turn my calculator on quick and do that. 5 probability combination 2, answer is 10. There are 10 ways that we can select 2 cards from among 5. The probability of drawing 2 cards and having those 2 cards add up to 5 when the 5 cards are numbered 1, 2, 3, 4, and 5 is equal to 1/5. Or there's a 20% probability.